That has like an extra bits at the end.
So
Yeah, put that bloopers.
Yeah, like bloopers at the end.
bloopers. All right.
Oh, that'd be funny.
Honest to gosh. Right.
Why is it?
Coil of wire. You're all going to know the answer to this question, though, aren't you? If you've got a current running through this, everyone say it together. It's called a
Solenoid!
Yay! I'll tell you what. For Friday afternoon, you're all very excited. That's proof. You put an iron core into the middle of it. You attached it to paper clips, and they all stuck, which is proof that you have got a magnetic field inside the solenoid. If we have a current going through a coil of wire, we've got a magnetic field inside the coil. If I put an iron core into that magnetic field, what happens to the iron core? It becomes a magnet. Now, right-hand rule says that when I change the direction of the current, I change the direction of the magnetic field. So, if I have my current going that way, my current is going that way around the wire. If I have my current going that way, I have got my current going that way around the wire. If I have got a current that is constantly changing, then my magnetic field is also going to be changing direction. Let's look at the facts we've got. A coil of wire, current running through it makes a magnet. Putting an iron core into the coil of wire makes the iron core magnetic. The direction of the current affects the direction of the magnetic field around the wire. If I change the direction of the current, I change the direction of the magnetic field. Happy with that so far? Okay. Next set of facts. If I have a normal coil of wire, and I put a magnet through that coil of wire, forwards and backwards. And if I connect that coil of wire to an ammeter, I will detect current flowing through that wire when the magnet goes in and when the magnet goes out. You saw me do that with a microammeter. Coil of wire, magnet, in, out, current came out. Say it again? Shake all about it. I just wish I could have gotten that into the, yeah. Take your magnet in, take your magnet out, in, out, in, out.
Shaking it to table so it's just not there.
Field.
Do the hug.
Yeah, we'll figure something out. Anyway, we got distracted. So, you saw me put a physical magnet through a coil of wire, and that coil of wire then had an induced current. Induced meaning it has been made to be so. An induced current and an induced voltage. Happy with those facts?
Yes.
Okay. A transformer just combines all of those facts. It allows us to induce a current and a voltage in a coil of wire without any current going to it. The only connection between one coil in your transformer and the next coil in your transformer is the magnetic field. The magnetic field is going through those two cores. They are separated by space. There is nothing in there. There's no connection between that wire and that wire. But over here, I have got a current moving through the wire. And it's changing direction. A current running through a wire makes a magnetic field. This magnetic field that's made in the core is produced by this coil, by this solenoid. Because it's an alternating current, the current is alternating direction, which means the magnetic field is alternating direction. So just like me putting a magnet through a coil, forwards and backwards, this has got a magnet going through it as well, but it's a magnetic field. It's not a physical magnet moving through the coil, it's the field of the magnet, the magnetic field of the core moving through the core in different directions.
Why does it matter that it changed direction? Can't it just go around in a circle?
It could,
But because of the alternating
it could,
current.
but because it's an alternating current, it's going to happen more often. Let's think about it. Theory. Cuts once, twice, but it has to go all the way around. Whereas if I can make it go forwards and backwards really fast, it happens more efficiently.
Right.
I'm going to stick with that for now. And if it's wrong, let me know.
The comments below.
Like and subscribe.
Make sure to click the bell button.
They're saying stuff. And if any of that's inappropriate, then I'm going to get fired, you know?
Yeah, it's all appropriate.
Okay. Let's combine this all together into the big picture I gave you. Oh, it's all right in there for me. Oh, it's all right. Right, okay, so in this example, that is also available, that's available online as well. The red lines are my current, the blue lines are my magnetic fields. Okay, it's the end of the school day. Red lines are current, the blue lines are the magnetic field. My current is changing forwards and back here is because I've got a source of AC current, alternating current here. So it's something over here is generating, like that thing, that little twisty generator I've got. Something over here is making electricity. It's an alternating current. It's moving forwards and backwards really fast. Every time the current changes direction, the magnetic field changes direction too. Okay? Look at these. There's some arrows there in the blue line. They kind of zip by every now and again. When the current changes direction, the magnetic field of the core changes direction. Every time you see those arrows go through that coil of wire there, they're inducing a current and a voltage. An alternating current, when it's passed through a coil of wire, makes it a solenoid. The magnetic field produced in the coil follows the right-hand rule. That means if the current changes direction, according to the right-hand rule, the magnetic field will change direction. Because the current is changing direction, the magnetic field is changing direction, we call that an alternating magnetic field. Because it's changing direction. When the magnetic field lines cross the electrical field lines, it induces a current, it induces a voltage. To induce means to make for a short period of time. It makes a current, it makes a voltage. And this whole process is called generator effect. Now we'll look tomorrow, no we won't, because tomorrow's Saturday and even I'm not that cruel. We'll look on Monday about how adding more coils to either side affects this whole thing. But for now, are you happy with this just as it is?
Yes.
Yes.
Mm-hmm.